One last video for 3.3. In this video, we're going to kind of combine everything we learned in 3.3 with a little bit of what we learned in 3.2. So in this example, we're going to write equations parallel and perpendicular to this line. 2x plus 3y equals 6. And it has to go through this point, negative 4 comma 5. So every time you have a point and a slope, which we're going to find from this equation, we're going to use the point-slope equation. So the best way to find slope from this equation is to put it into slope-intercept form. So I'm going to say 3y, I'm going to subtract 2x from each side, equals negative 2x plus 6. And then I'm going to divide by 3. So y is by itself and it's in slope-intercept form. Divide by 3, divide by 3, divide by 3. Y equals negative 2/3 x plus 2. So now we have our slope. M equals negative 2/3. Okay? All right. Now we have our point, and we're going to write two equations of lines. Let's do parallel first. What's the relationship of slopes of parallel lines? They're the same. So the slope of this line is negative 2/3. That means that the slope of our parallel line is going to be negative 2/3, but it has to go through this point. So we're going to use y minus y1 equals m times x minus x1. And we're going to use this for x1 and y1, and our m is right here, okay? So let's go y minus 5 equals negative 2/3 times x minus negative 4, all right? And we'll call this x plus 4 because minus negative 4, that's what that is. Now, I'm going to say y minus 5 equals, and I'll distribute negative 2/3 to the x and to the 4. So negative 2/3 times x is negative 2/3 x. Negative 2/3 times 4 is minus 8/3. Then, to get y by itself, to get it in slope-intercept form, I'm going to add 5, but I want to add 5 in the form of thirds. How many thirds would that be? How about 15? 15 over 3 is the same as 5. So now I get y equals negative 2/3 x, and then 15 over 3 is negative 8 over 3 plus 15 over 3 is plus 7 over 3. So that's great. That's in slope-intercept form. But we're also going to have to write this equation in standard form too. We want to get familiar with writing them in both forms. So to get it in standard form, I'm going to add the 2/3 x over. So this is my slope-intercept form. That's great. But now I'm going to add the 2/3 x over so that I would get 2/3 x plus y equals 7/3. Then I need to do one more thing to get it in standard form, which is to multiply by 3. And if I multiply by 3 on both sides, well, this 3 is going to cancel. I'm going to have 3y, and this 3 is going to cancel. And I get 2x plus 3y equals 7. So I have two great forms of an equation that is parallel to this original line and goes through that point. You would graph this by finding the intercept and using the slope, or by finding the x and y intercepts, you get the same line. And it would be parallel to this line, and it would go through this point. Okay, so these are my slope-intercept equation and my standard form equation for the line that's parallel. But we also have to do the perpendicular line, okay? So I'm going to erase this. I'm going to erase this work. Everybody got it? You can always go back and pause it if you want to. So here we go. So it's going to go through the same point, but instead of being parallel to this line, it's going to be perpendicular. Well, we found the slope of this line already. The slope of this line is negative 2/3. So what are we going to use for m for the perpendicular line? The opposite reciprocal. So m that we're going to use is going to be positive 3/2. Right? So now we'll have y minus 5 equals, let's see, 3/2 times x, and then minus x1 minus negative 4. I think you'll like this one a little more because the fractions are going to be a little easier to work with. Let's see, so I'm going to simplify, I'm going to solve for y to get slope-intercept form. So y minus 5, and if I distribute, I get 3/2 x, and this is going to be plus 4. Well, 3 times 4 is 12. 12/2 is plus 6, okay? All right, now let's get it into slope-intercept form by adding 5 to both sides. So if I add 5 and add 5, y equals 3/2 x plus 11. And then now I want to get, so that's slope-intercept form. That's one very useful equation because we can identify the slope and the intercept and easily graph. It's a neat line. It's perpendicular to this original line. Goes through that point, right? Okay, now let's move this, the x term over to the left side so we can look at standard form. So I'm going to minus 3/2 x minus 3/2 x. Now continue over here. Okay, I'm going to move my new equation so I have negative 3/2 x and then plus y equals 11. All right. Now, I just need to get rid of that fraction and I need to make the a term positive. What should I multiply to do both of those? How about times by negative 2? So negative 2 times negative 3 is positive 6/2 would be positive 3x. Negative 2 times y would be negative 2y. And then negative 2 times 11 would be negative 22. Okay. Wow, that was a great problem. Standard form. Let's recap. First, we found the slope of this line. We found it to be negative 2/3. We wrote an equation that was parallel by using the same slope and going through that point using point-slope form. And then we solved for y to find slope-intercept. We also put in standard form. Then we repeated that process, but we used a different slope because we wanted to find the perpendicular line, which is the opposite reciprocal slope. So we used, for the second time we repeated the process, we used a slope of positive 3/2. We found its slope-intercept form, and we found its standard form. Now if you could graph all 3 lines on one graph, and you would find that the first equation that we found would be parallel, second perpendicular, and the 2 equations that we came up with would go through that point. Thank you so much. That wraps up 3.3. So we're going to skip 3.4. 3.5 is a fun one, it's functions, and then we can review for the test. I'm really excited. Okay, all right, thank you very much.